What I'm going to do for today, we're going to do quadratic formula today, but before I do that, I could sit here and just show you what the quadratic formula is and show you how to use it, but I think I'd be doing you a disservice because I want you to see where it comes from. On Friday, we learn about the completing the square. And in order to figure out how to get the quadratic formula, because we're actually going to come up with it on our own, right? I'm not just going to say, here it is, learn it, this is how you use it. I want you to be able to develop it and come up with it. I think this is a good thing for you to be able to do. I don't know if you saw this in Algebra 2 or not. I'm not sure if your teacher showed you how they came up with the quadratic formula or just showed you what it was, but I'm going to show you how to come up with it. Before we do that, let's do a little review since we've had the weekend off. I'm going to do actually number 13 from problem set 10. And I want to do it by completing the square because I want to practice a little bit so that it's kind of in your head a little bit before we do this, that whole completing the square thing. Because completing the square has got a lot to do with the quadratic formula. So first thing I'm going to do, if I was going to solve for this is number 13 on the problem set 10, the one we just went over. Alright, so I'm going to, first of all, I'm going to put this in the correct order. They call it descending order. Actually, that's a plus 5, right? Do you see what I did with that minus 5? I moved it to the left-hand side. I did that by adding it. So now it's a plus 5. And I stuck it equal to 0. All right? Now, just to kind of get us into what we're going to do next, watch. I'm going to call that first. This is a coefficient. That number in front of the variable, that's a coefficient. So that coefficient I'm going to call A. What's the coefficient in front of this x right here? Yeah, it would be B. What's the actual number? It's a 1, isn't it? Okay, and this constant right here, we'll call that C. So this is the A, this is the B, excuse me, and this is the C. You with me? All right, I'm going to go through this a little bit quick, so just follow along here. First thing I do is I get rid of the 3. So I divide everything by 3 because I want that coefficient to be 1 in front of that x squared. So if I divide everything by 3, let's see what I get. I get x squared plus, now instead of writing it x over 3, I'm going to write it 1/3 x plus 5/3 equals 0. Okay, why did I put divide by 0 here? Somebody stop me. That should be a 3, right? I guess I was thinking ahead of what that was going to equal. This thing keeps shaking. There we go. All right, with me so far? That's all we've done. We just divided everything by 3. No big deal. Now what I'm going to do is I'm going to complete the square. So I'll put a plus 1/3 x. Watch what I'm going to do. I'm going to put a plus. I'm going to leave this blank right here. Sometimes I'll put a little underline here just to show that that's a blank spot. And what I'm going to do is take that 5/3, I'm going to chuck it to the other side. So how do I do that? I could have just kept it over there at the beginning if I wanted to, but I like to have it set equal to 0 so it all looks similar. So I'm going to take this and put it back to the right side. So this time I would subtract, and this time it's a 5/3, isn't it, instead of just a 5, because I divided by 3. Alright, so now I'm ready to complete the square. I got to figure out what goes in this spot. Well, we got 2 steps in order to find out what goes in this spot. We take half of the middle term, right, the middle coefficient, we take half of it, and then we square it. So if you need to, let's come off to the side. Let's take 1/3, let's take half of it, and let's square it. So what's that going to be? That's 1/6 squared, and what's 1/6 squared? It's just 1 over 36. It's easy, right? Square the 1, square the 6, no big deal. So this is 1 over 36. Well, look what I did. I added it to this side. I can't just randomly add a 1 over 36 to the left side. I'm going to have to also do that to the right side. Now I've made this into a perfect square. By taking half of this and squaring it, this makes this, and putting it right here, that makes it into a perfect square. When I say a perfect square, it means put it in parentheses, put a squared on the outside. That means a perfect square. So I put x here. Always look to that sign. That's what goes in the middle. And then I can do it 2 ways. I could either take half of this one, or I could take the square root of this one. It doesn't make any difference. That goes right here. And so that's a 1/6 equals. Now we got to add these fractions up. It's not that big of a deal. 3 times what? 12, right? So 5 times 12, and that's negative 60. So that's easy to add. Find a common denominator. It's not that hard. Negative 60 plus 1 is negative 59 over 36. Now, we have to solve for x. Take the square root of both sides. I don't like to put the big old square root because it just makes things too messy. I know it's going to go away, don't you? So I just get rid of it. So I take the square root of this side, but I also have to take the square root of the other side. Put a plus or minus in front of that square root. We talked about that Friday. Now let's subtract a 1/6 from both sides. So x equals negative 1/6 plus or minus. Now let's look at this. It's going to be the square root of 59. And then that, what do we do with that negative inside that? It becomes an I, doesn't it? Over square root of 36. See what I did? I took the square root of the top and I took the square root of the bottom. So the square root of 36 is just a 6. All right? And you could just keep it just like that if you wanted to. And that's probably a good way to write it. Now, it does have a common denominator of 6. You could write it all over just 1/6, but I kind of like this because this is a complex number. This is the real part. This is the imaginary part. And we've separated the real and the imaginary. And I think that's a good way to write it. Look in your book in the back on problem set 10. Do it real quick. Somebody do that for me. Look at number 13, problem set 10. Tell me how they write it. The exact same way? Okay, that's what I thought. All right, I was pretty sure that they would do this because, again, this is the real part. This is the imaginary part. All right? Does that look familiar? Yeah, we did that on Friday. I don't expect you to completely master it, but maybe you have it now. You learned it in Algebra 2. I know that. But we learned it Friday, and you're going to see this problem. Again, you know how this book works, right? You're not just going to see it one day. You see it the next day, the next day, the next day, the next day. So make sure that you know how to complete the square. All right, with that in mind, a lot of the steps that we did here, you're going to find very familiar with what we're going to do next. Because remember, I said this is A, this is B, and this is C. So what I'm going to do right now, I want to solve for a general, this is called a quadratic equation. Did you ever hear that? Okay, it's called a quadratic. And this is a quadratic equation. We haven't done the formula yet. That's what we're working our way up to. This is called the quadratic equation because it's equal to something. When you have something x squared plus something x plus a constant equaling 0, that fits this pattern of a quadratic equation. So let's write it like that. Watch what we're going to do. We're going to write it, instead of 3x squared, I'm going to be real general and not just specifically call it 3. What am I going to call it? A, what? X squared plus, what do you think? Instead of plus 1x, we're going to write what? Plus bx. And then instead of plus 5, we're going to write plus c equals what? 0. So this is a general quadratic equation right here. And we could throw numbers in for a, b, and c, couldn't we? Right? And right here, what was our a? Our a was 3, our b was 1, and our c was 5. Make sense? So the a, b, and the c represent numbers, coefficients. In this case, a constant, but they represent numbers that could go in that spot right here. So what I'm going to do, I am going to do the quadratic, or I'm going to complete the square, not with a 3, a 1, and a 5 as my coefficients, but I'm going to complete the square with a what? With an a b, and a c as my coefficients. Do you see it? And I'm going to work this thing down, I'm going to do all this work, and I'm going to come up with what? X equals something. That's what I'm going to do. But I'm going to have a bunch of letters in here instead of a bunch of these numbers. Okay, it's not going to come out to all numbers. It's going to come out to actually letters and numbers. And you look at this and you say, well, how can that come out with numbers? It doesn't even have any numbers in it to begin with. How in the world can I introduce any numbers here? Well, you'll see in a second. All right? You guys look excited about getting ready to do this. I'm kind of excited. It's kind of cool. I like doing this. It's kind of fun. You ever doodle? You ever sit and, I hate to say this, but you ever sit in church and stuff and you kind of mind wander, you start doodling? This is what I doodle. It is. I'm not kidding you. All right, let's get rid of all this stuff and then we'll, yeah, I'm a dork. That's all right. All right, so, and you should do the same thing. You should doodle this stuff. Not in church, though. I'm not telling you to doodle during church. But if you doodle math, okay? You may just want to sit and watch instead of write this down, okay? If you really want to write this down, you can always look at the YouTube video and go back. But just sit and just try to concentrate. Don't let your mind wander, though, all right? So just really focus on what we're doing here. So we're solving for x. That's what we're trying to solve for right here. And we're going to do this by completing the square. What do you think our first step is? What was our first step in that other problem? We got rid of the 3, right? So what are we going to do here? Divide by a. Good. So divide this side by a, and this one, and the other side. All right, so look what we get. That cancels out. let's give myself a little bit more room over here. So I've got x squared plus, instead of bx over a, let's write it b over a and then x. Make sense? Okay, plus c over a equals 0, because 0 over a is 0. Now this is not a perfect square, so I'm going to take this c over a and I'm going to chuck it to the other side. Remember doing that in the other problem? So we've got x squared plus b over a x. Leave a blank. I'll put a plus. I'll just leave a blank right here. I won't put the underline. Equals what? Is it c over a? Negative c over a, right? Because we subtract it from both sides. Now we got to figure out what's going to go here. We got to complete the square. We want to fill this in with a number so that this becomes a perfect square. And we learned a little trick to do that. We take this middle coefficient, we take half of it, and then we square it. So let's come over here off to the side. Let's take b over a. Let's take half of it, and then we're going to square it. So let's see what that gives us. b over what? 2a, right? Would you agree? And we square it. That's not hard to square. What is that? b squared over, what's that? 4a squared. Remember I said we're going to have some numbers in here? Look at that. There's our first number. Do you see it? Looks like it just came out of nowhere, but it didn't because we took half of it and we squared it. That's why we got the 1/4. You got it? So now what am I going to do? I'm going to add it to both sides. I'm going to add it to this side, b squared over 4a squared. And I'm going to add it to the other side, b squared over 4a squared. It's all making sense, isn't it, so far? It just kind of follows the pattern of doing that other problem. Now look, looks kind of ugly, but it's not so bad because it's a perfect square now. I made it into a perfect square. What goes here? X. Always look to that sign. That always goes right here. Now what do? You either take half of this or you take the square root of this. And that's going to give us what? B over 2a. Do you see that? It's either half of the middle one, right? So if I take half of b over a, it's b over 2a. Or I can take the square root of this. Square root of b squared is b, square root of 4 is 2, square root of a squared is a. Equals. Now, here we go. This is probably the hardest part of the whole thing for most students. Just find a common denominator. It's really not that hard. I got an a, got a 4a squared. The common denominator is 4a squared. What'd you do to a to get this? You multiplied it by 4a. So what do you do to the top? Multiply that by 4a. So I get negative 4ac plus, I didn't do anything to this denominator. Well, I multiplied it by 1, so I just multiply the top by 1, or just keep it the same. Alright, we're getting there. It's looking a little uglier the more we go, isn't it? But that's okay. You're going to see some things that look pretty familiar to you, I think. Now watch, instead of negative 4ac plus b squared, let's just clean it. Let's make it look a little prettier. I always like the squared to go first. So I'm going to go b squared minus 4ac. That just looks a lot nicer. That's the only reason I did that. See, I just switched the two. It's no big deal. Alright, now what do? We've got to get rid of the squared. Square root both sides. So watch, take a big old square root. What do we put in front of that square root? Plus or minus. Follows the steps exactly what we did earlier. Subtract a b over 2a from both sides. So watch, I get minus b over 2a plus or minus. Now look, I take the square root of the top and I take the square root of the bottom. So let's take the square root of the top and I get b squared minus 4ac. That will not simplify. Don't try to take the square root of that squared because I can't take the square root of 4ac over. But I can take the square root of the bottom. Take the square root of this, right? Because I take the square root of the top and the bottom, and I get a 2a. Now, instead of leaving them separate like this, like we did that other problem, it does have a common denominator of 2a. So here we go. Watch. Here it is. See if this looks familiar to you at all. It's going to be what? Negative b plus or minus square root b squared minus 4ac, and it's over the common denominator, which is just a 2a. Does that look familiar to you? Yeah, it should. And at this point, it needs to be memorized. Okay, you have to memorize the quadratic formula. This is something that you should not graduate from high school without knowing. All right, know the quadratic formula. There it is. Wasn't that fun? Really, was it much different than that problem that we did earlier? It wasn't much different at all. All right, you just had variables instead of numbers, but look, you actually ended up with a couple numbers in here, didn't you? All right, let's do a problem where it's an example of using this, and then we'll be done.